Hello everyone, welcome to my new programming club. Today we will solving another Leetcode daily challenge and the challenge name is course schedule. So the challenge statement goes like this. There are total of num course courses you have to take labeled from 0 to num courses minus 1. Okay, so it's saying is there are, let's say, 5 courses. Those are numbered from 0 to 5 minus 1, which is 4. You are given an array prerequisites where prerequisites I ith index of prerequisites array is AIBI indicates that you must take BI course first if you want to take course AI. So what the problem statement or the challenge statement is saying is, if the prerequisite array is like this 1 0 2 3, and this is a array at the ith index of prerequisite array. So to take first course, you have to take 0th course first. It means that first course is having a dependency on 0th course. Similarly, second course is having a dependency on third course. For example, pretty much the same example is stated here. We have to check or return true if we can finish all the courses given this number of courses and prerequisite array. Otherwise, we have to return false. So this is the problem statement, and the constraints are: the number of courses is between 1 and 2000. Prerequisite array's length is between 0 to 5000. And each index of the prerequisite array is having an array of two lengths. So their courses are present in the pair inside prerequisite array. So these are the constants for the courses courses indications 1 2 3 4. So that's what the problem statement is asking, and these are the constraints. And it's also mentioned that all the pairs in prerequisite array are unique, so there are no repetitions of any pairs. So let's take an example. Let me clear the board. For example, if this is the case, this is array at ith index of prerequisite array. Here course AI is dependent at BI, so we can make a directed edge of a graph from BI to AI to denote the dependency of course AI to course BI. So this is what we will be doing to generate a graph from the given prerequisite array. For example, let the generated graph be like this. These directed edges denote that these nodes 2, 5 are having dependencies on 1 and 4. Means you have to first complete 1 and 4 before touching 2 and 5. Similarly, for the other nodes also. Let's know, okay, that's fine. Then what we will be doing is, for each of the node, for example, let's say here for 5, we will be forming a graph like structure where for each node 5 we will be listing its neighbors. Neighbors are those nodes in the graph which are dependent on fifth course or fifth node. Those are 3 and 6. For 1 it would be 2. For 2 it would be 3. For 4 it would be 5. And for 5 we have listed. For 3 it would be nothing, empty. For 6 it would also be nothing, empty. So this is the case. So in order to check whether we would be able to take up all the courses, or you can say finish all the courses, we should first be starting to touch those courses who do not have any dependency or any another course as of now. So as of now, let dependencies be marked in a array called degree, or you can say dependency, where each index in the array denotes a node in this graph. Indices be 1, 0, 1, 2, 3, 4, 5, 6. Okay. So let's say there was another node, 0th node, and it was not dependent on anyone, and it was on its own. So let's initialize all the values in this array as 0. Means as of now, any of the node is not having dependency on any another node. Then as we traverse our prerequisite array, as soon as we encounter a pair, we will simply be decreasing value at AI index of this degree or dependency array. So for example, here 0, here for example 4, the directory is like from 4 to 5, means 5 is dependent on 4. So we will be decreasing the degree of fifth index in degree array, which is now from 0 it has become -1. Similarly, for third index is dependent on two of the courses. First, it is dependent on 2 to 2, and then it's dependent on 5 also. So there would be a pair like this in the prerequisite array, given prerequisite array. uh, Pardon please, it has to be other way around, like this and like this. So what we would be doing is, we would simply be decreasing the value of the first node in the pair, the value of first node in the pair in degree array. So third index will be having -2. So these are nothing but the dependencies. -2 indicates that it's dependent on two nodes or two courses. -1 indicates that it's dependent on single course. So till now I hope this is clear. Let me quickly erase the board. Or let me just take this example to the next slide. That would be a nicer thing to do. Okay. Now what we will be doing is, we will be forming the degree array, or you can say dependency array, and the indices will be 1, 0, 1, 2, 3, 4, 5 and 6. So here the all the values are initially 0. Then we will be marking their dependencies by decreasing their value. So for example, 3 would be having dependency of 2, 6 would be having dependency of 1, 5 would be having dependency of 1, and then 4 would be having dependency of 0, as it's not dependent on any other course, and 2 would be having dependency of -1, 1 would be having dependency of 0, and 0 would also be having dependency of 0. So at first, to check whether we can take up all the courses or finish all the courses, we would be taking those courses first which are not having any dependency. For example, here these are the courses that are not, let me quickly change the color, that are not having any dependency over any other course. So we would be first visiting these courses or taking these courses or finishing them, for example, and then also while finishing them we would be checking their neighbors and increasing or relieving their neighbors of their dependency, meaning that the course on which they were dependent is now finished, so they are no longer dependent on that. For example, 0 does not have any neighbors, or you can say courses depending on it, so we can safely mark 0 as done. Then again we would be visiting 1. It have only one course dependent on it, which is 2. So after marking 1 as done, we would be going to its neighbor and relaxing its dependency. What we would be doing is, we would be simply be increasing the value of 2 in degree array, the value of second index in degree array, which will now become 0. So as soon as the degree of a node or the dependency of a node becomes 0, we would be considering it for our next part. We would be using a queue-like structure, First, these three nodes 0, 1 and 4 will be in queue. Now as they are popping out, 0 did not have any neighbor, 1 had one neighbor. After relaxing, which whose dependency became 0, so we will be enqueuing that in the queue. And in similar way, after being finished with fourth course, we would be relaxing the dependency of fifth course, and it would become 0. And if it have become 0, we would be including it in the queue, and the cycle goes on. So at last, and we will be keeping a variable count courses to check whether how many courses we have finished till now. And if at last the number of courses finished is equal to the given number of courses, let the given number of courses be CRS, and is equal to the finished courses, which is equal to count courses, then we can say that we can finish all the courses given the constraints of the prerequisite array. So this is the approach of the problem. Let's move towards the coding part. And before moving towards the coding part, you may ask, there would be a situation if something like this is given. So the second course is dependent on first course, and there would be a cycle situation. Basically, the dependency would be like that there would be existing a cycle. So how we would be preventing this situation, loop condition? So we have already taken care of that while picking only those nodes whose current dependency is 0. So we would be avoiding that, and that's pretty much it. Let's move towards the coding part. And also, this traversal that we are doing is called BFS, breadth first search. Those of you who do not know what breadth first search is, I will be providing link for a article which will be describing what breadth first search is, and this manner of making a degree array and taking those nodes first which do not have any dependency. This type of traversal is called topological sort. Topological sort. I will be also providing link for this also. So let's move towards the coding part. So here I have taken the length of the prerequisite array, and if the length is 0, means any course is not having dependency on any another course, in that case we will simply be returning true. It means that we can finish all the courses, and then we will be initializing our degree array, this degree array, or you can say dependency array. And initially in Java, all the values of the array are 0, so we do not have to initialize all the values as 0 here, at least in Java. So then we will be generating a graph. This is the graph that we will be generating. This is the graph. So this is the graph we are generating according to the dependencies given in the prerequisite array. So we will be making a directed as from the second node in the pair to the first node in the pair, and we will also be simultaneously making our populating our degree array by decreasing the value at the first node in the given pair in degree array. So we have built a helper function which is try to finish course, and we will simply be returning whether we have been succeeded in finishing all the courses. So this method would be taking a argument as a graph argument, three arguments. One would be the graph that we have made, and then second would be the number of courses given, and third would be the degree array that we have made. And then we would be here, this is a simple BFS traversal, with a little modification that we would first be enqueuing only those courses whose degree is 0, courses which are not having dependency so they would be added in the queue first, means they would be finished first since they are not having any dependency. So if the current course under consideration is this, and we have to relax all its neighbors by increasing the dependency value in the degree array. Here what we are doing is relaxing neighbors and simultaneously we are checking that if after relaxing the degree of the course or user node have become 0, means is it still dependent on some course. If that's not the case and the dependency is 0, we would simply be enqueuing it in our queue this way that I have described here, and then we will simply be continuing till our queue will become empty. And with each current course considered, we will be simply increasing the counter of the number of courses finished. So at last we would simply be checking whether the number of courses finished is equal to the number of courses given, and that's pretty much about the problem. And the code would be available in both of the languages, C++ and Java, and it would be available on the GitHub repository. Also, we have created a LinkedIn page for the programming club. I will be giving link to the LinkedIn page in the description of the video, and you can subscribe to our channel for more such content. Thanks for watching. Thank you.